Alright, geometry students, so today our lesson is all about midpoint and distance. To be successful today, we should be able to determine the midpoint and length of a segment on the coordinate plane using coordinates. And so in this lesson we will talk about how to find the length of a segment, the midpoint of a segment, and also practice a little bit of algebra. But before we move on, it is so important to make sure you refresh your memory of the Pythagorean theorem first. If you don't know, the Pythagorean theorem is one of those cornerstone principles in math that can be applied to a variety of things, including the distance formula, which we will see in a moment. Again, remember, stop here if you are not quite familiar with the Pythagorean theorem. Watch the video I've provided, and then make sure that you have your guided notes ready. Those are going to allow you to follow along with this video. All right, here we go. So, first things first, we need to talk about the distance formula. And the distance formula is really just the Pythagorean theorem revised. We know that the Pythagorean theorem says that one leg of a right triangle squared plus the other leg squared is equal to the hypotenuse, or the longest side across from the right angle, squared. The distance formula does the exact same thing, it's just written a little bit differently, and you don't need a coordinate plane necessarily to use it. So again, the distance formula is used to find the distance between 2 points. Let me clean up those lines here. The distance between 2 points. So let's say those points are called x1, y1. That's one of the points, and x2, y2, that's the second point. So the distance formula looks like this. It says d for distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And let me break this down a little bit for you and show you why it's similar to the Pythagorean theorem. So x2 minus x1 is just the horizontal distance from point A to point B on the coordinate plane. It's the horizontal distance. You take your x values and subtract them from each other to get that distance. And y2 minus y1 is the vertical distance. Y is our coordinate, which allows us to move up and down on the y-axis. So here you go. So this is the square root of the horizontal distance squared plus the vertical distance squared. Let's practice. So I have our distance formula up here to refer to, and you can see we have a coordinate plane. And we are asked to find the distance between the 2 points on the graph. Let me start out by labeling those points. So the first point, let's call it A, and that is at -5, +3. -5, 3. And B is at -2, -3. Okay. So here's where the Pythagorean theorem might come in handy. And really, the Pythagorean theorem and the distance formula are the same thing. So the horizontal distance between these 2 points can be shown as the leg on a right triangle. This is the horizontal distance in green. You can see that horizontal distance is 3. And the vertical distance, the change in y, is this purple line. Draw that a little straighter. It's this purple line here. And so this is 1, 2, 3, 4, 5, 6 units. So you can see these are the legs of a right triangle, and the length of the segment is the hypotenuse of that triangle. So you could very well write the Pythagorean theorem. This would be 6 squared plus 3 squared is equal to the distance of the segment squared. And you could solve for d. Here's the same thing written in the context of the distance formula. Distance is equal to our coordinates. So again, reminder, here's our coordinates, A and B. A is -5, 3. B is -2, -3. So first we want to subtract the x values from each other. And the order doesn't necessarily matter. I know we see x2, x1, but as long as we're subtracting the x values and the y values in the same order, it doesn't really make a difference. So let's just start with -5 minus -2 squared. The difference between the x values squared plus the difference in the y values squared. So this, in the same order, would be 3 minus -3. 3 minus -3 squared. And now all we need to do is simplify to find the length of segment AB. So here we go. This would be, so -5 minus -2 is just -5 plus 2, and that would give us -3 squared. Plus 3 minus -3 is really just 3 plus 3, so that is 6 squared. And -3 squared is +9. 6 squared is +36. So when we simplify, we get the square root of 45. And when we approximate that length, it is about, to the nearest tenth, 6.7 units. If we were to solve using the Pythagorean theorem, like I did over below the coordinate plane, d would also be approximately 6.7, or the square root of 45. They're the same thing. One is using algebra, the other is just using order of operations. So let's try one without a grid. This is where the distance formula comes in handy. Of course, you could always graph this, but really you can use the distance formula, no problem. So again, you have points A and B, and we're asked to find the length of AB. So let's start our distance formula. Distance is equal to the square root of the difference between the x values squared, so -4 minus 3 squared, plus the difference in the y values squared, so 1 minus -1 squared. And I'm going to simplify. Start by simplifying what's in the parentheses. -4 minus 3 is -7. 1 minus -1 is 2. We're going to square our values here. -7 squared is +49. 2 squared is 4. So we have simplified to get the square root of 53. And when we estimate the square root of 53 to the nearest tenth, we get about 7.3 units. The length of segment AB is 7.3 units. There is another practice problem just for using the distance formula, and that is problem number 3 in your notes. Let's move on to the midpoint formula. So the midpoint formula is used to find the midpoint, the center point between 2 points. This could be the midpoint of a segment, whatever it might be. So the formula for this is really just finding the average between the x and y values. So m for midpoint is x1 plus x2 divided by 2. Take the x values, add them together, divide by 2 to find the average. And then you do the same thing with the y values. y1 plus y2 over 2. Very simple. Find the average of the x and y values to find the midpoint of a segment, or the halfway point between 2 points. Let's try this out. We're going to find the midpoint of segment GH given G, which is 7, negative 5, and H, which is 9, negative 1. So let's write this out. The midpoint between those points is going to be, so the two x values are 7 and 9. We need to add them together. Divide by 2. The y values are negative 5 and negative 1. Add them together. Negative 5 plus negative 1. Divide by 2. And so we get 7 plus 9 is 16 over 2. And negative 5 plus negative 1 is negative 6 over 2. And to simplify one more time, our midpoint coordinate is 8, negative 3. And if you were to plot all of these points on the coordinate grid, you could easily prove using the distance formula that this is exactly the midpoint between points G and H. There is another additional practice problem for using the midpoint formula, and that is problem 5. So stop here if you would like to practice. Right, we're going to apply the midpoint formula in a different way to find a missing endpoint. I've included the midpoint formula up above for reference. So number 6 says we need to find the coordinates of A if M is at negative 1, positive 2, and it's the midpoint of segment AB, and B has the coordinates of 3, negative 5. What's helpful here is to draw a picture. So we need to know the coordinates of A. Let's just draw a segment and a midpoint. It doesn't matter that it's not on the coordinate plane in the correct position. I just want to know where A, M, and B are in the segment AB. So A, B, and M is the midpoint. So this lets me know that where to substitute values into the midpoint formula. And what we're going to end up doing is creating two equations. One is to find x, the x value, and the other is to find the y value. Because notice we have two expressions in this coordinate. So let's set this up. I know that the coordinate of the midpoint, the x coordinate of the midpoint, is negative 1. So negative 1 is going to be equal to the average of the x values of A and B. So I know that the x value for B is 3. So 3 plus my missing x value divided by 2. That's my equation to find x. Now I want to find y. I know that my midpoint, my y value midpoint is positive 2. Positive 2 is equal to the y value of one of the endpoints, so that's negative 5, plus the missing y coordinate divided by 2. And so now we're going to go solve these equations. First thing I want to do when I'm finding the x coordinate here is I'm going to multiply both sides by 2. Multiply both sides by 2. So now I get negative 2 is equal to 3 plus x. Of course, these canceled out here. And now we're going to subtract 3 from both sides to isolate x. And we get -5 is equal to x. Now let's find the y-coordinate. Again, multiplying both sides of the equation by 2. And I get +4 is equal to -5 plus y. I'm going to add 5 to both sides. And 9 is the y value. So my coordinate is -5, +9, and that's A. We were trying to find the coordinates of A. There are a couple others to practice here, and that's 7 and 8 in your notes. All right, one more concept. We're just going to practice with a little bit more algebra today. And our last problem looks like this. If P is the midpoint of x, y, xp is equal to 8x minus 2, and py is equal to 12x minus 30, we need to find the value of x. There's a lot going on here, and again, I advise that we draw a picture for sure. So it would look something like this. I know my whole segment is xy. So xy here. And the midpoint is P. I know that xp is the expression 8x minus 2. I know that py is the expression 12x minus 30. And I know that since P is the midpoint, these two portions of the whole segment are congruent to each other. They're the same measure. So I need to set up an equation to solve for x. Since they are the same measure, I'm going to set those two expressions equal to each other. And it should look something like this. 8x minus 2 is equal to 12x minus 30. So now I'm going to move my variables to one side of the equation. So I get -2 is equal to 4x minus 30. I'm going to add 30 to both sides to move the constants to the left side. I get +28 is equal to 4x. Divide both sides by 4. And x is going to equal 7. Now what I could do to check my answer, I'm not going to do that right now, but what I could do is I could take the value of x, 7, and plug it into 8x minus 2 and 12x minus 30. If they equal each other, I did my work correctly. Again, there are 2 additional practice problems, that is 10 and 11 in your notes. So that was it. Thank you for watching. Make sure that you're trying out the additional practice problems to solidify what you learned. Check your answers with my filled-in notes by going to the content library in the Topic 1 Notes tab. And of course, ask for support in the Math Help Desk channel if needed. Thanks again for watching.